Hi guys! I'm Raissa Nethania or Narcise from 3MM, and for today, I'll be discussing about derivatives. But first, what is a derivative and what are the various applications of this? Derivative as the rate of change in rate measurer. Practical daily life examples include the rate of change of volume of a solid with respect to one of its dimensions, velocity and acceleration in rectilinear motion, to find out the marginal cost and revenue cost of any product, such as in economics, statistics, and finance, heights and distances in trigonometry, and many more. Why do we need to study derivatives? Calculus is the mathematics of change, and the derivative is the tool we use to find the instantaneous rate of change, and it is the basis of calculus. What mathematical skills are needed in order to solve derivative problems correctly and more efficiently? There are 3 mathematical skills needed in order to solve derivative problems. First, you should master solving different equations in advanced algebra. Second, you should know how to find derivative using different rules. Third, you should know how to analyze different problems in order to know when are you going to apply the rules for finding the derivatives. Now, let us try to solve derivative problem. Our problem is about revenue. The marketing department of Telecom has determined that the demand for their cordless phones obeys the relationship P is equal to negative 0.02x plus 600, where P denotes the phone's unit price in dollars and X denotes the quantity demanded. Find the revenue function, find the marginal revenue function, compute R prime 10,000, and interpret the results. So our given P is equal to negative 0.02x plus 600, where x is greater than or equal to 0 and x is less than or equal to 30,000. We're going to find for A, revenue function, B, marginal revenue function, and C is we're going to compute for R prime 10,000. And so for the first one, we're going to find for the revenue function, which is denoted by Rx. Our formula for revenue function is Rx is equal to x times P, where x is the quantity demanded and P is the phone's unit price. In here, we're just going to substitute the value of P to the formula. So we have Rx is equal to x times negative 0.02x plus 600 and distribute x. So we will have Rx is equal to negative 0.02x squared plus 600x. So here's our first answer, which is the revenue function. And for the next one, we're going to find the marginal revenue function. We'll just simply get the derivative of the revenue function, which is the answer we got earlier. This is Rx is equal to negative 0.02x squared plus 600x. So to get the derivative, we'll just apply the power rule. So we're going to have R prime x is equal to 2 multiplied by negative 0.02x plus 600. So distribute 2. We will have R prime x is equal to negative 0.04x plus 600. So here's our second answer. This is our marginal revenue function. And for the last one, we're going to compute for R prime 10,000. Substitute 10,000 to x in the marginal revenue function, which is our answer earlier. R prime x is equal to negative 0.04x plus 600. And again, Rx is equal to 10,000. So once we substitute 10,000, we will have R prime 10,000 is equal to negative 0.04 times 10,000 plus 600. And once we multiply negative 0.04 to 10,000, we will get negative 400. So we have R prime 10,000 is equal to negative 400 plus 600, and we will get 200. So our R prime 10,000 is equal to 200. And for the last, our interpretation, the revenue corresponding to the sale of the 10,000 first phone is about $200. And that's all. Thank you for watching, and I hope you learned a lot.